In this module, you will come to learn about the comparative mortality index, and in order to know that, one must also understand the need for standardization of mortality data as well as the methods of standardization, as the comparative mortality index is a standardized index arrived at through an indirect method of standardization of crude death rates. As you would have seen in the earlier module, and as is also discussed in this module, the crude death rate is only a crude measure and masks the various differences in the population, for which the age structure is one such important variable. As the crude death rate is weighted by the proportion of the population within each category, within each age category. Therefore, comparing across populations becomes difficult, as the population composition is different and would be more valid if the age structure of the population were the same. For instance, one country may have a higher crude death rate than another country, but this could be mainly because the first country has a very high proportion of older persons and is therefore not an accurate comparison, or it can be said that age is a variable that confounds the comparison. This can also be considered for the same population across different periods of time. Therefore, in order to make comparisons across populations, we would need to carry out a process of standardization with regard to age composition of the population. Comparative mortality indices are computed by applying standard mortality rates to different groups of the population studied in order to obtain an expected number of deaths, and then comparing the observed deaths in the population with these expected deaths. The comparative mortality index is arrived at through a method of direct standardization, which is a simple and preferred method to arrive at age-adjusted death rates, and it depends heavily on the standard population, such that it would change if the standard population were to change. One of the main disadvantages of the comparative mortality index is its instability, particularly when there are small number of deaths, such that a change in any one death would affect the comparative mortality index. More is discussed in the following module.
I am Dr. C.P. Prakasham, retired professor from International Institute for Population Sciences, Mumbai. Module 35, Comparative Mortality Index. Learning objective. In this module, you will learn number 1, how to compute comparative mortality index. Number 2, meaning. Number 3, with an illustration. Here you will be seeing that infant mortality and economic freedom quartile. If you see that in the left side, least freedom quartile, infant mortality is very high. Third quartile, infant mortality is little less. And if you see that moderate freedom quartile, you will find infant mortality is low. That means from the least to moderate freedom quartile is very declining over the quartiles. Crude death rate will depend upon the age structure of population as well as on the level of mortality. If the mortality of different populations is to be compared, standardized mortality rates or adjusted mortality rates are sometimes computed to eliminate the effect of difference in population structure. Comparative mortality indices are computed by applying standard mortality rate to the different groups of population studied and summing these to obtain an expected number of deaths. The indices are then obtained by comparing the observed deaths in population with expected deaths which would have occurred had the standard rates applied. Comparative mortality index. The term comparative mortality index can be used to express one mortality rate compared to other when both have the same base. Comparative mortality ratio equals to death rate of 1 divided by death rate of 2 multiplied by 100, where the two death rates have common base. The meaning of comparative mortality index is the ratio of expected number of deaths arrived by direct standardization to the actual deaths. Example 1. Data given as below in table 1. It shows US 2002, Venezuela 2002 and world as a standard. Here if you look at the crude death rate of US in 2002 is 8.5, Venezuela is 4.2 crude death rate and world as a standard as 5.0 as crude death rate. In the direct standardization, considering world age-specific death rates as a standard compared with the age structure of population of US 2002, the direct standardization of death rate is given as 5.5 per 1000 population, and as well as Venezuela is 5.8 per 1000 population. Examining this, it shows clearly making the standard world age-specific death rates and comparing the Venezuela and US population structure, it shows clearly that crude death rate of Venezuela is higher than the crude death rate of US. Similarly, when you consider the indirect standardization, that means considering the population structure of US and comparing the age-specific mortality rates of the world, then US shows 6.8 as a indirect standardization crude death rate, whereas Venezuela is 3.9. Further discussion will be shown in the next one. The meaning of comparative mortality index is the ratio of expected number of deaths arrived by direct standardization to the actual deaths. In table 1, this comparative mortality ratio for the US is 100, that is 5.5 divided by 8.5, that is 65%, and for Venezuela is 100 multiplied by 5.8 divided by 4.2, that is 138%. This again is heavily dependent on age structure chosen as standard. The utility of comparative mortality ratio increases when calculated for standardized rates. The ratio for the US compared to Venezuela in table 1 is 100 multiplied by 5.5 divided by 5.8, that is 95%. Since both rates refer to the same standard population, this can be interpreted as saying that the death rate in the US is 95% of that in Venezuela. Although both rates under comparison are standardized for the same age structure, yet the effect of the chosen standard is not eliminated. If another standard age structure is chosen, the ratio can become different. Example. An example is given of difference in mortality figures of Turkish and Dutch men in the Netherlands between the ages of 0 to 44 years. The analysis has been by various causes of death in the year 1979 to 1988. Using the comparative mortality figures CMF 1.575 with Dutchmen as the standard, the findings were that mortality rate of Turkish men up to age 45 were more than 1.5 times higher than that of the Dutchman, not constant over age group, and is more than 1.5 times in the case of children. Using reverse standardization, where Turkish men were used as standard instead of CMF, was 0.619. Further analysis is the report. Citation below. Source: Statistics Netherlands 2013. Method of standardization available online at so and so given link. Reference: Brussels and D, page 64 at the following link on the instability of CMF using fictitious data. Reference 3, SMR and CMF and the difference between them at the following link. Julius Nicolo and George 2001. Why do we continue to use standardized mortality ratios for small area comparison? Journal of Public Health Medicine 23, volume 11, 40 to 46 pages, available at the following